Hi, I'm Andrew Brust with Pluralsight, and this module is What is NoSQL? The point of this module is to get you acquainted with the qualities that the various NoSQL databases have in common. And with that, our first point of business is going to be to list out a number of those common traits. As it turns out, there are a number of different NoSQL databases. They break down into separate subcategories. But before we actually explore that and investigate it, it's important to understand what all these different products have in common. So we'll start with those common traits, and then there are a few qualities of NoSQL databases that we'll want to drill down on and treat individually. So we'll look at the way NoSQL databases handle database consistency. We'll look at how they handle indexing. We'll look at the ways that you can query NoSQL databases. We'll look at a computation algorithm called MapReduce, which, while it's not NoSQL in and of itself, it's an approach that is employed by a number of NoSQL databases. So it's important to understand how it works, at least at a high level. And then we'll finish up by looking at a partitioning pattern that many NoSQL databases use called sharding. So let's take a look at that list of common traits before we get into the into some of the individual ones in more detail. So the thing about the term NoSQL is it's a little bit of a misnomer, quite frankly. NoSQL databases, actually a couple of them will support SQL, structured query language, as an interface to query the data inside the database. But what you will find is that really no NoSQL database is relational. The whole idea of normalized data modeling and joining of tables really doesn't exist in the NoSQL world. If you've done any work with databases going back into the 80s that were file-based, it's almost as if that model has made a bit of a comeback here. However, there really are two traits of NoSQL databases that are the ones you should really commit to memory. So the non-relational approach is one of them. The other one is the idea that these databases can be either schema-free or at least what I might call schema-flexible. And that means, just to put it in plain English, that as you go from one record to the next record within the same table or whatever the container might be called, it kind of varies by the type of database, the type of NoSQL database. When you go from one record to the other, you may find that the structure of those records actually differs. It may differ just at a detailed level. It may differ in a very fundamental way. And that is a very common trait of NoSQL databases as well. So again, the two you want to commit to memory really are the ones that you see up on the screen right here. The non-relational aspect of these products and the sort of liberal approach to schema. But there are a few others. You don't necessarily need to commit them to memory, but we do need to discuss them here. There's eventual consistency. Now, this is the way NoSQL databases deal with the idea of taking instruction from you and acting on it, or not acting on it, as the case may be. When you go to add a new record or update an existing one, most NoSQL databases will process that request very quickly. But processing the request and actually implementing the request are two different things. So a number of these products actually delay the work of doing the update. And in the case where things are kind of clustered, and we'll talk about that in a second, even if the work is done in a relatively short time frame on one member of the cluster, it may take a while to reach some of the others. Now, the advantage of this is that you tell the database what you want to do. It gives you back control very quickly, and you go on to the next thing. What you give up in return for that very sort of limited burden of waiting for processing to complete is that the changes you've asked for may take a while to propagate out. That's really the trade-off, and the whole theme of trade-offs is a constant one when you look at NoSQL and when you're coming from a different database model, most specifically relational. You'll also find that most NoSQL databases are open source. Many of them actually come from Apache open source projects, although not all of them are Apache projects, but most of them are open source. And there really is another kind of level to the open source quality of these databases, which is that developers who work themselves with open source tools and languages tend to be more interested perhaps in using NoSQL as the repository for their applications than those coming from more proprietary kind of enterprise stacks such as Java and .NET. Of course, Java itself has an open source quality to it, but the individual application servers tend to be commercial products. So you'll find that those who develop with open source tools and languages also tend to have a fondness for NoSQL databases, and so you'll see NoSQL more prevalently there, although you'll see it in the more commercial enterprise stacks as well. Most NoSQL databases are also distributed databases. Now, this is actually a really important point because although relational databases can also act in a very distributed way, there tends to be a lot of work involved in that, and that tends to be something that gets set up in special circumstances. With NoSQL databases, that's actually fairly typical, fairly standard, I would say. And the distributed nature is interesting because it means that the data can be split amongst multiple nodes in a cluster, i.e. servers, in a grouping of servers. But what it also means is that the data on one server may well be replicated on another. That provides for fault tolerance. It also provides for a certain geographic distribution of data and allows applications that are geographically dispersed to operate in a more responsive way at the edges of the networks. And that really dovetails into this idea of web scale applications. And that's a term that gets bandied about, not necessarily so rigorously defined. But what I would say with respect to NoSQL is that there are a number of applications out there. They're large, they're public, they tend to be consumer facing, and the databases that underlie them tend to be rather unsophisticated. However, the sheer volume of users overall and also concurrent users ends up creating such a demand, such a burden on the system that although the needs are relatively simple, those simple needs need to be met very, very quickly. So although the database looks innocent to begin with, the fact that it's so big and needs to be so responsive creates requirements that are not run-of-the-mill at all, but are actually very special. And NoSQL databases tend to be optimized to that particular scenario or that set of scenarios. And as such, you'll find that a lot of NoSQL databases have their heritage in projects at big internet companies like Yahoo and Google and Facebook, even LinkedIn. All of these are sites that have, had to pioneer the idea of building technologies that work well with these web scale scenarios. So it's not surprising that a lot of these products kind of emanate from those kinds of companies.